Hello everyone, my name is Ben and welcome to this video tutorial on the hexadecimal number system. We learned in the past couple of video tutorials about, counting and binary and how to convert from binary to decimal and from decimal to binary. But this is a new number system that we're going to be introduced to. And so let's think about the word hexadecimal to figure out how many numbers are going to be in this number system. So if we look at the word decimal, we know that stands for 10. And then the word hex, if you take in geometry, you probably learned about a hexagon, and that has 6 sides. So we could say the word hex stands for 6. And so if we put those together, add 10 plus 6, we get 16. So we're going to get 16 digits that we're going to be used in the hexadecimal number system. So this is a base 16 system. So let's figure out what those 16 digits are. So with the decimal system, we learned that we had 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So those are 10 digits. So that covers the 10 digits. Now, where do we get the other 6 digits? So since we're out of actual numbers from 0 to 9, what the hexadecimal system does is it's going to start out, we need to figure out what the other 6 numbers are. So for 10, 11, 12, 13, 14, and 15. So that'll make up our 16. That'll make up our 16 numbers. But instead of using 10, 11, 12, 13, 14, 15, we're going to use the letters in the alphabet. So that's what the hexadecimal system, how it works. So for 10, we use the letter A. For 11, we use the letter B. 12, we use the letter C. 13, we use the letter D. 14, we use the letter E. And 15, we use the letter F. So, to recap what we just did with the hexadecimal system, we had the first 10 digits, 0 through 9, and then the other 6 remaining digits, we just use the first 6 letters in the alphabet. A equals 10, B equals 11, C equals 12, D equals 13, E equals 14, and F equals 15. So, let's see how we can convert a binary number into hexadecimal number. So what we're going to do is, let's say we have a binary number. We have 1, 0, 1, 1, 0, 1, 0, 1. And let's say, we want to convert this binary number into a hexadecimal number. So the way that we're going to do this is we're going to divide the binary number into 4 bits each. So here's 4 bits, 0, 1, 0, 1. And then here's 4 bits here, 1, 0, 1, 1. And 4 bits is a term they use. It's just called a nibble. Kind of a silly term. When you think about nibble, you think about just nibbling on some kind of food or something like that, but that's what they actually call 4 bits, is a nibble. So we have 2 nibbles here. We have one right here, 1 0 1 1, and then we have another one, 0 1 0 1. So we have 2 nibbles. And for each nibble, we're going to figure out, what the hexadecimal value is going to be. So if we look at the first nibble, that's 1 0 1 1. What we're going to do is determine what that number is, because we know how to convert to decimal. And just looking at it, we have, let's see, we have a 1 in the 8's place. We have a 1 in the 2's place, and a 1 in the 1's place. And 8 plus 2 plus 1 equals 11. So we get 11 from that binary number, 1 0 1 1. So that's the decimal number 11. And so if we go over here to our hexadecimal number system, we see that the number 11 is actually equal to B. So for this first nibble that we have, 1 0 1 1, we're going to use the letter B. And then we'll do exactly the same thing with the other nibble, 0 1 0 1. So we know we have a 1 in the 4's place, and we have a 1 in the 1's place. So if you look at that from the last video we did, 1 0 1, the 0 to the left of 1 is not really counted. That's just an extra bit. So we have 4 plus 1 equals 5. And so that's just the number 5. So this whole number here, we can say that 1 0 1 1 0 1 0 1 in base 2 equals B5 in base 16 for hexadecimal. So that's our number, B5. Okay, so that gives us an idea, how to convert from binary to decimal. Now, what if we wanted to convert a hexadecimal number into decimal? And so what we could do is we'll write over here. Let's say I have the number B2C. So if I have the hexadecimal number B2C and I want to convert this into decimal, I'm going to look at what the place values for each of these. And since we're using base 16, we're going to be using the powers of 16 to convert this. So if we look at our places here, we have 16 to the 0 power, or just 1, 16 to the first power, that's 16, and 16 to the second power, that is 16 times 16 is 256. So you can see the numbers are going to increase very fast once you proceed further to the left. and so on. So just looking at this here, we know that with the B, if we look at B, that's 11. So we know that we're going to do 11 and then multiply that by 16, second power, plus, then we're going to have the value 2, multiply that by 16, the first power, 16, and then plus C is the value 12. So C is 12, so that's going to be 12 times 16 to the 0 power is 1. So that's just that. And so we'll need a calculator here, or you can do this by hand if you like. But 11 times 16 squared, that's 256. So let's see what 256 times 11 is. So that's going to be 2,816. Okay, so we'll write that up here. 2,816. And then 2 times 16, that's 32. So we'll write that there. And 12 times 1 is 12. So we'll just add all those together. And so we have 6 plus 2 is 8. 8 plus 2 is 10. Carry the 1. 1, 2. 2 plus 3 is 5. 6. 1. And then bring down the 8 and the 2. So it looks like we're going to get B2C in base 16 is equal to the decimal number 2,860. Pretty big number. Okay, so let's see what else we could do here with the hexadecimal system. We're going to clear the board. So we did binary to hexadecimal. We also did hexadecimal to decimal. What if we want to go the other way around? Say we want a decimal number and then we want to convert that to hexadecimal. So let's say we have the number 264. So this is the decimal number 264, and we want to convert this to hexadecimal. So the way we could do this is we'll convert this to binary first, binary number, and then once we have the binary number, we can use the nibble method that we did, 4 bits each, to convert to hexadecimal. So instead of just doing dividing by 2 repeatedly like we did with conversions, we can actually go to just the placeholders and just do our powers of 2 to figure out what binary number equals 264. So we know we're going to need several places here. Okay, so let's go with these one at a time. We'll just count by our powers of 2. So we start with 1, 2, 4, 8, 16, 32, 64, 128, 256, and then we can stop right there because the next one will be 512, and that's too large for 264. So we know that the 264 is equal to 256 plus 8. So we know we're going to have a 1 here in the 256th place, and we're also going to have a 1 here with the 8, and then the rest are going to be zeros. Okay, so what we're going to do is we know that that's the binary number. We have 1, 0, 0, 0, 0, 1, 0, 0, 0. So that is the binary number for 264. Now to convert to hexadecimal, we're going to have to divide these up into the nibbles, the 4 bits. We have 4 bits here. 2, 3. We have 4 bits here. And we have to include this 1 here. So the way we can create that is just to include some leading zeros. 3 leading zeros here. And that'll create our third nibble. So now we're going to do each of these nibbles, starting with the left one to the far left. So 0, 0, 0, 1. And we see that that's just equal to 1, right? So that's in the 1's place. And then we have the next one, 0, 0, 0. Well, that's just equal to 0. It's no value. And then we also have the last nibble, 1, 0, 0, 0. So that's 1, 2, 4, 8. So that's so that would give us 8. So just putting these, having this as 1, this is 0, and then this is 8. We know that 264, the decimal number, base 10, is equal to the hexadecimal number 108 and base 16. Okay, so that's how you would do that one. So that's pretty much it, for this video. Just wanted to introduce to you the hexadecimal system, what digits we use, how to convert from that to binary, hexadecimal to decimal, and then even decimal back to hexadecimal, which we just did in this example. So this has been, and I want to thank you for watching this video tutorial on the hexadecimal number system, and please stay tuned for more math videos, and I will see you next time. Take care. Have a good day. Bye-bye.